Okay, so we're finishing up our 6.7 notes. We've got 3 problems left to do, and then we are done. So these are our special sequences for the last thing that we're looking at. Okay, so we need to figure out the pattern. The pattern is not arithmetic. The pattern is not geometric, but there is a pattern. So we couldn't write the explicit rule because it's not arithmetic, it's not geometric, but we actually can write a recursive rule. The recursive rule is just going to tell us how do we get to the next number in the sequence. So if we look at the pattern on number 20, to go from 2 to 4 to 6 to 10 to 16 to 26, does anybody see that pattern? Well, 2 plus 4 gives me 6. 4 plus 6 gives me 10. 6 plus 10 gives me 16. 10 plus 16 gives me 26. So 16 plus 26 would be how I would find the next number. It would be 42. And then I would do 26 plus 42 to get the next one, which would be 68. So I can find the next 2 numbers in the sequence. So how do I write that as a recursive rule? Well, I start by writing what a sub 1 is always. A sub 1 is equal to 2. And then to find the next number in the sequence, so to find a sub n, I actually have to take the 2 previous terms before it. So I actually have to take a sub n minus 1 and I add that to a sub n minus 2. In other words, I take the term before it plus the term that's 2 before it. And because this sequence actually requires you to have an a sub n minus 1 and a sub n minus 2, that means you need 2 terms. So I can't just list the first term. I actually have to list a sub 2 as well, which would be 4. So you have to say the first 2 terms because you needed 2 terms to be able to get to the third term. And then you need the next 2 terms to get those. So see if you can find the special pattern on 21 and 22 and see if then you can write it. Okay, so to go from 1 to 3 to negative 2 to 5 to negative 7, I'm actually taking subtraction. So 1 minus 3 is negative 2. 3 minus negative 2 is actually 5. Negative 2 minus 5 is actually negative 7. So I'm going to have to list 2 terms for this one. So a sub 1, that's an a sub 1, sorry, my pen carried. A sub 1 is 1, and a sub 2 is 3. So to find the next term in the sequence, I actually subtract the 2. So I'm subtracting the one that's 2 away from it minus the one that's 1 away from it. That would be how I would show that I'm taking this term minus this one to get to this one. Taking the one that's 2 before it, so if I'm looking for this number here, I'm subtracting the one that's 2 before it minus the one that's 1 before it. And try number 22, see if you can get that one as well. All right, so the pattern on this one, to go from 1 to 2 to 2 to 2, and then up to 4, I'm actually doing 1 times 2 is 2. Then 2 times 2 is 4. Then 2 times 4 is 8. And 4 times 8 is 32. And 8 times 32 would give me 256. And then 256 times 32, multiply those 2 together, would actually give me 8,192. So how do I write this one? Well, a sub 1 is equal to 1, and a sub 2 is equal to 2. If we're using 2 terms, we have to have the first 2 terms listed of our sequence. So to get to my next term, a sub n, what am I doing? I'm multiplying the 2 terms before it. So I have a sub n minus 1 times a sub n minus 2. And the order of this one didn't matter. So if you had a sub n minus 2 listed first, that's okay. And again, you need all 3 parts of this to be able to write it. So we can't write an explicit formula for these because they're not arithmetic, they're not geometric, but they do have a pattern. And if they have a pattern, we can extend that pattern. And if we can extend that pattern, we can write a recursive rule for it. All right, take a second and write your summary.